Hey everyone, welcome back. Today, we're diving into a groundbreaking study that's revolutionizing how doctors understand and treat epilepsy. Ever wondered how complex brain data translates into life-changing medical decisions? Let's unpack this research and see how machine learning is turning seizures into actionable insights. Epilepsy is a neurological disorder marked by sudden, uncontrolled electrical storms in the brain, seizures that can vary wildly in severity and origin. For many patients, traditional imaging like MRI or EEG fails to pinpoint the exact source. But here's the breakthrough. Researchers have discovered that during seizures, the brain emits unique electrical patterns. Think of them as chirps. These aren't random noise. They're encoded signals that reveal where seizures originate and how they spread. But how do you decode this? Enter machine learning and a technique called t-SNE. Imagine t-SNE as a master cartographer. It takes high-dimensional data, like the timing, frequency, and shape of these chirps, and compresses it into a 2D map. This simplification lets scientists spot hidden patterns that would otherwise be invisible in raw data. Here's where things get really interesting. The team didn't just map the data, they trained models to predict patient outcomes. They tested 4 machine learning algorithms: random forest, SVM, logistic regression, and k-nearest neighbors. The results? Random forest and KNN dominated, correctly predicting optimal surgical outcomes in nearly 89% of cases. That's a game changer for identifying which patients will benefit most from surgery. But the real innovation? They used SHAP, Shapley additive explanations, to create sensitivity maps. Think of this as highlighting the most critical clues on their t-SNE map. These maps revealed that specific chirp features, like rapid frequency shifts, strongly influence clustering. This gives neurosurgeons a roadmap to target seizure origins with precision. So why does this matter? Epilepsy affects over 50 million people globally, and for many, surgery is a last resort. This research could refine surgical planning, improve success rates, and reduce unnecessary procedures. It's a prime example of how AI transforms raw data into clinical tools, making the invisible visible. Let's break down the data. The study analyzed thousands of cases, categorizing them by surgical difficulty. Shockingly, 45.5% were classified as very difficult, highlighting the need for better predictive tools. Using t-SNE, researchers visualized these cases, coloring data points by outcomes, success, no resection, failure, and difficulty levels. The maps showed clear clusters, revealing how complex cases diverge in the data space. Now here's the technical deep dive. They tested models across 3 scenarios, distinguishing success from failure, separating high difficulty from low difficulty cases, and identifying optimal outcomes. K-nearest neighbors and random forest excelled, achieving 88.8% accuracy in spotting cases where surgery would be both successful and straightforward. But how do these models see the data? Let's clarify. Random forest acts like a committee of decision trees, combining rules to create complex boundaries. SVMs draw a straight line, maximizing separation between groups, while logistic regression uses probabilistic thresholds. K-nearest neighbors, meanwhile, identifies patterns by proximity, like a neighborhood vote. The team also experimented with feature weighting, adjusting the importance of variables like seizure duration or spectral range. By amplifying certain features, they uncovered critical predictors. For example, emphasizing seizure duration highlighted cases where longer episodes correlated with treatment resistance. This isn't just about accuracy, it's about interpretability. SHAP values quantify each feature's impact, turning abstract models into transparent tools. Surgeons can now prioritize chirp characteristics linked to success, bridging the gap between data and decision-making. In the end, this research isn't just about algorithms. It's about transforming epilepsy care, one data point at a time. As AI continues to evolve, studies like this show how machine learning isn't just a tool. It's a partner in unlocking the brain's most complex mysteries. Thanks for watching. Stay curious and keep exploring the intersection of science and technology. Until next time.